The year is 1907, a time of great scientific curiosity and discovery. Excitement crackled in the air of the physics labs. Something big was brewing, something that would push the boundaries of human knowledge, something that would change how we see the universe forever, altering our understanding of the cosmos. Our story follows a young, bright-eyed physicist named Thomas, who was eager to make his mark. Thomas, like many of his peers, found himself captivated by a new mystery, the nature of light and matter, a puzzle that had baffled scientists for generations. For centuries, scientists believed light was a wave, a continuous flow of energy. But new experiments began to challenge this long-held belief, suggesting a different reality. Could light also act like a stream of tiny particles? This radical idea was gaining traction. This question consumed Thomas's every waking moment, driving him to explore the unknown with relentless determination. To unravel this enigma, Thomas decided to recreate a classic experiment, the double-slit experiment. The setup was simple, yet elegant. Imagine a wall with two tiny slits close together. Behind the wall is a screen that glows when hit by light. By shining light at the slits and observing the pattern on the screen, one could learn about the nature of light itself. First, Thomas closed one slit and shone light through the other. The result was predictable. A bright band on the screen directly behind the open slit. Light, it seemed, traveled in straight lines, like tiny bullets. This made perfect sense if light were made of particles. But the real test was about to begin. With a deep breath, Thomas opened the second slit. Section 4. 2 slits. The unexpected. The moment both slits were open, something astonishing happened. Instead of two bright bands, a pattern of alternating light and dark bands emerged on the screen, an interference pattern. This was a signature of waves. When two waves meet, they interfere with each other, creating areas of high and low intensity. The pattern on the screen was undeniable proof light behaved like a wave, or did it? Section 5. 1 by 1. Still a mystery. Determined to solve this perplexing puzzle, Thomas decided to fire individual particles of light photons, one by one towards the slits, hoping to uncover the truth. If light were truly a wave, even single photons should create the interference pattern just like a continuous wave would. To his astonishment, they did. The results were beyond his expectations. Even though each photon passed through only one slit at a time, over time, the same interference pattern emerged on the screen, as if by magic. It was as if each photon mysteriously knew about the existence of both slits, defying conventional understanding and leaving scientists in awe. Section 6. The observer effect. The mystery deepened when Thomas decided to observe which slit each photon actually went through. He placed a detector near the slits. Now he could track each photon's path. But here's the truly bizarre part. The moment Thomas started observing, the interference pattern disappeared. The photons started behaving like particles again, passing through one slit at a time and creating two distinct bands on the screen. It was as if the act of observation itself influenced the outcome. Section 7. A new era of science. Thomas's experiment, along with the groundbreaking work of many other pioneering scientists, shook the very foundations of classical physics. It revealed the strange and counterintuitive world of quantum mechanics, a realm where the rules of the macroscopic world no longer applied. The famous double-slit experiment demonstrated that light, and indeed all matter, could exhibit properties of both a wave and a particle simultaneously. This experiment introduced the baffling concept of wave-particle duality and the observer effect, forcing scientists to completely rethink their understanding of reality and the nature of observation. This groundbreaking experiment wasn't just about light, it was about the fundamental nature of the universe itself, challenging our perceptions of existence. It marked the birth of quantum theory, a scientific revolution that continues to shape our understanding of the world and the universe today. And so the quest to understand the universe continues, driven by curiosity and the desire to uncover the unknown. New discoveries await those curious enough to ask the big questions and brave enough to seek the answers. Like Thomas, embrace the wonder and never stop exploring the mysteries of our universe, for the journey of discovery is endless and ever rewarding.